Piecewise 4. The first two problems on piecewise 4 are similar to things we've already done on 1, 2, and 3. So it's the third problem that has something new. So when we look at this one, it looks similar, maybe we think, to what happened on piecewise 2, but notice, not a segment, ray, segment, ray. So I have a horizontal ray left, a horizontal ray right, and then a segment in the middle. So when f of x equals 4, x is less than -1, horizontal ray left, I've got my endpoint. When f of x equals -3, I have two endpoints, so I'm a horizontal segment in the middle, and I have two endpoints, the first closed and the second open. And then when I come to the bottom one, f of x equals 1, when x is greater than 2, I have a horizontal ray to the left, and I have a to the right, and I have an endpoint. Forgot to open my markers using my teeth. So for the first one, -1, 4. So I find -1, 1, 2, 3, 4. That's open. It's a horizontal ray left, and so I simply take my ray and I go left. And because I have my blue one open, not my pink one, I'm going to do the pink and blue. So I have a closed endpoint at -1, -3. So I'll make that nice and closed. And then at 2, -3, I have an open endpoint, and that's just a horizontal segment. So I went ahead and graphed it. Now for the bottom one, f of x equals 1. When x is greater than 2, the endpoint is closed at 2, 1. So at 2, 1, it's closed, and I know it's heading right. And so here is the pieced graph. It has 3 pieces. For the horizontal line, y equals 4, it starts at -1 and goes left. For the horizontal line, y equals -3, it cuts off the left and right pieces and just takes this little portion. And for the horizontal line, y equals 1, it doesn't want the whole line, it just wants to start the line at 2, 1 and take it. We see that these are jumps, and so we know we're not continuous at -1 and 2. Now, the second example is going to be more exploration of parabolas. That's what we're going to be doing on the last 3 problems. And so here we have a parabola going left, a parabola going right, and we have an ordered pair in the middle. Now notice this one's opening down, and so if I'm trying to draw it, it would, that was supposed to be green. Pretend like it's green. It's supposed to be going down, and then this one is still heading up and to the right. Yeah, this makes me feel bad, so, because you're going to look at the video and somebody's just going to look at the colors and then whine. So that's my best job of doing the parabola when I redid it. And so my table, we're always just using 1s and 4s or -1s and 4s, and the left side or the right side, and we'll see the vertex was supposed to say 0, 2, and of course she wrote 0, 0, and it's 0, 2. Down here it's 0, 2 also. All right, so it's 0, 2, but notice the x-coordinates match, so I get half the parabola. So I start at 0, 2, and at 0, 2, I'm going to put a nice open circle in, and then I want to go left 1, down 1, back up here, left 2, and down 4. And so I now have my graph, and so I have for myself half of a parabola. And so then my ordered pair is 0, -3, and 0, -3, is right here. So I'll make it nice and big so we can see it. That's 0, -3. And then I want to put in 0, 2. Oh, it's already there, but it's open and it's a parabola. Notice that these two agreed. When these two agree and a single point doesn't, we're going to get a new name of a discontinuity. So it's a parabola, and I'm going right 1, up 1. Back here, I'm going to go right 2 and up 4. And I'm going to draw my parabola. 1, 2, 3. I didn't make it up hard enough. I thought I missed it. 1, 2, 3, 4. We'll get it up there, folks. And so there's going to be my parabola. Notice, if it were legal to come here, now it's not, but let's say it were legal, and I could come up here and see, I could just sneak and fill that in. Is it now not continuous? And whenever we can do that, the discontinuity that occurs is called a hole or a point discontinuity. It simply means, oh, if you can fill in the point and it looks continuous, then we say a point has been missing. But we couldn't do that here because the point is indeed missing, and that's our graph, and it's called a hole. Now, for the fifth graph that you're going to be doing, I'm going to put an oblique line with a parabola. Notice this is an oblique line. So it's an oblique ray on the left and a parabolic ray on the right. The oblique ray is going downhill and the parabola is opening up. And so when I come down here, I want to go left. So I'm using the slope 3 up and 1 left when I go to do it. So let me plot my 0, 2. So my 0, 2 was a closed circle up here. And now I want to do my slope up 3, left 1, 1, 2, 3. 1, 2, 3. And now I can draw my oblique ray. Gotta live with what you got, people. And now for my parabola, again, notice the x-coordinates match. So it's half the parabola. That's what I'm doing to you all the time, at least on these first few sheets. And since I'm heading to the right and I see the coefficient of x squared is positive, I'm just going to first find the ordered pair 0, 1, which is open. Then I'm going to go right 1, up 1. Then I'm going to go right 2 and up 1, 2, 3, 4. And I'll draw my parabolic segment. And so this is just an oblique ray to the left with negative slope. Notice you say, oh, what, I'm going up. No, you aren't. We read left to right, you're heading down. And when we read left to right, you're heading up. So this is decreasing and this is increasing. So again, because I can't fill that point in and these two be connected, this is what we call a jump for our discontinuity. Now the last graph that we're going to do is going to be two parabolas again and an ordered pair in the middle. Notice a parabolic ray to the left, and it's a positive, so I want the top half left. But notice this parabola opens down, so I want the bottom half right. And so I notice none of these points match, so I'm back to what we call our jumps. So I'm going to plot 0, -2, open. So 0, -2 is open. And now I want to go left 1, up 1, and then I go back and I go left 2, up 4. And trying to draw the left side of a parabola. Then my single ordered pair is going to be 0, 1. So I plot 0, 1, nice and big so you all can see it. And then I'm going to come over, and now when I do my parabola, it's going to open down and to the right. And the vertex for this one is 0, positive 2, but it's an open circle. Let me get this one to right, okay. And so right 1, down 1, back up here, right 2, down 4. And so it's going to look like this. Parabola opens up on the left half. Parabola opening down on the right half. You've done graphs like this where this one went up, that went down, and you found the point of intersection. But now we're just drawing the pieces.